So this is a video on function transformations, the A and D transformations, and you'll understand what that is in a minute. Just want to lay some groundwork. The first thing is function transformations mean I'm taking a function and transforming it. So it must always start with a parent function. So this in here is the parent function that we will start with. This is the linear parent function. So we're going to do a function transformation based on the linear parent function. I want to do some stuff that you already know. So in red, I'm going to put this graph on. Blue, I'm going to put this graph on. And in yellow, I'm going to put this graph on. Before I put the last one on, notice that 2x is just a slope of 2 that has a y-intercept of 0. 1/3 x is a slope of 1/3 with a y-intercept of 0, but they're all pointing positive direction, up to the right, up to the right. Obviously, the parent function is up to the right. The only thing that's changing is this is either getting steeper or flatter. And we're going to change those words, so I want you to imagine that there's a rubber band on the end of this, and if I pull it up, so if I stretch it up, this is going to stretch up and go higher. If I pull that rubber band down, it's going to make this go flatter. So I'm going to stretch up and I'm going to flatten down or stretch down. The word for stretching down is compressing. So I'm going to stretch and I'm going to compress. Now I'm going to put the negative 3/2 slope on. Notice that what happened here was I am no longer rising to the right. I am falling to the right. This you learned in Algebra 1 is a negative slope. Positive slope up to the right, negative slope down to the right. I also want you to imagine what would have happened if I had just taken this red line and reflected across the y-axis. So this red point would have come down here. This red point would have come up here. So in effect, I would have reflected that over the y-axis. So a couple important words that you learned are stretch, compress, and reflect over the y-axis. Now I'm going to fill in the parent table over here, but instead of what I'm going to do is I'm just going to fill in the y's for the red graph, the y's for the blue graph, and the y's for the yellow graph. And notice when I fill in the y's for the red graph, if I put in -2, I'm getting -4. If I put in -1 as x, I'm getting -2. If I plug in 0 as x, I again get 0 and 2 and 4. So I want you to see here that on the red graph, all I did was multiply the x by 2, right? So I put the x in and doubled it. Notice in between this parent and this parent, all I did here was I multiplied by 2. I'm guessing you can guess what happens with the 1/3 graph. With the 1/3 graph, I don't really have beautiful points with the parent function, but what's going to happen with the blue graph is I'm going to multiply everything by 1/3. And instead of -2, I'm going to have -2/3. And instead of when I input the -1 as x, the y will come out as -1/3, again 0. If I input +1 into this blue graph right here, so if I input +1, I obviously get 1/3. And if I plug in +2, I'm obviously going to get 2/3. So that is the blue graph. So notice my parent is adjusting based on this number in the front. Okay, let's do the last yellow graph. If I input a -2 into the x right here, I'm going to get a positive 3. So let's go ahead and check that one. If I plug in a negative 2x, I should get a positive 3, and that's exactly what happens on this particular line. If I plug in negative 1 into here, I should get negative 1.5. So if I go to negative 1, I should get, a positive 1.5, which is approximately where this is, and it was done manually. So I will get a positive 1.5. If I plug in 0, if I plug in 1 into this right here, I'm going to get a negative 3/2. So if I go to positive 1, I should get a negative 1.5. And that's what I get there. And lastly, if I plug in 2, I should get negative 3. Again, notice all I did here was multiply by negative 3/2. What am I multiplying? I'm multiplying the current output by negative 3/2 and getting my result. Okay? If I were to write the transformational equation of a line, notice the exponent on here is a 1, okay? So it would be A times B times x minus c, close both of those, plus d. And what we just did was an A transformation. There was no B, there was no C, there was no D. So all I had was A times x, A and the x. There's no B, no C, no D. We're just looking at the A transformation. And if you remember from what we talked about, that did a few things. So an A transformation can do a vertical stretch, it can do a vertical compression, and it can do a reflection over the y-axis. Now, when you're talking about a vertical stretch and compression, remember it was a multiplier, right? This was a multiplier, I'm multiplying. So this is a vertical stretch by a factor of whatever your A value is. And it's the same thing as a compression, by a factor of whatever your A is. So again, we just looked at an A transformation. You will see how all of this gets put together when we work on some examples at the end. So in this particular page, you have this worksheet. So I want you to grab this worksheet, and the first thing I'm going to do is I'm going to pause and I'm going to make a table, a parent table. We are going to call this our parent. And remember the other day with domain and range activity, parents don't have to be pretty and they don't have to be conformed and everything. It just has to be a function. So we're going to call this f of x, and this is going to be our parent. So I'm going to pause and make that table and determine the domain and range. Now I want you to check your table and your domain and range. And I want to remind you that domain is always left to right. So I'm left at -4, right to +4. There are no arrows, so I only go from here to here. I use every x between -4 and 4. My range is bottom. The bottom of the graph is here, not here. So bottom, -3 to top, +2. And my domain and range are listed like this. I'm actually going to change that to black. So if you notice these two graphs, all I have is the A. Okay, so all I want to do is 2 times the function at x. So I put my parent function on here. I'm now going to put my parent table in. So what is on both of these graphs right now is not only my parent table, this is going to be my parent for the next few examples, my parent and my parent table. And what this is asking me is, what if I do 2 times the function at x? Well, the function at x is -3, and all I'm going to do is multiply by 2. So this new graph is going to be, I'm going to multiply by 2. So I'm going to get -6, 0, 2, 0, -4, and 4. All I did was take my y values and multiply them by 2, because what this says is 2 times the function evaluated at x. The function evaluated at x is right here. This is my x, this is my function evaluated at x. All it tells me to do is multiply it by 2. So I'm now going to put this new red graph on by using the original x and the new red y. It's very hard to draw these with a stylus that you can't see exactly where you're putting your point down. So there's my new red graph, and if you look, it looks like it was stretched. It looks like I took either end and stretched up and stretched down. Okay? So now we're going to put in the domain and the range. I know what the black domain and range is because I already have it up here. This is my original domain and range. What is my new red domain and range? I'm going to go left to right. So my new domain is 4 to 4. My new range is bottom to top. Well, the bottom of this is -6, and the top of this is 4. I want you to notice that my domain from my parent and my domain from my new red graph didn't change. This should be -4, shouldn't it? The domain didn't change because I didn't have anything to do with the domain. I was affecting the y's. I didn't change any of my x's. I only changed my y's. So my domain didn't change. Notice what happened to my range. I went from -3 to -6. I went from 2 to 4. What did I do between this range and this range? What did I do between this range and this range? You're right, I multiplied by 2. So notice, not only does this give me the multiplier on my output, my y value, but it also gives me the multiplier on my range. Now, what is this last sentence down here, the transformation? So now I want to say what the transformation was on this graph. So this is a vertical stretch by a factor of 2. All I did was a vertical stretch by a factor of 2. I need you to write that in there on the bottom of my screen or my controls for recording and pausing, so I can't actually get down here. So this line right here should say vertical, this line way down here on the bottom that I can't get to because of my stylus, should say vertical stretch by a factor of 2. I'm now going to look at the second graph and notice my parent stays the same. I'm still transforming f of x. So my parent is going to stay the same, but this time it's telling me to take 1/2 of the result of x of f of x. So I'm now going to multiply. It's telling me to take my output and multiplying it by 1/2. I'm going to pause and do that and graph it. And again, it's very hard with the stylus when you can't see, but you know that in here, this is a straight line going, come on, from here to here. Then I have a little humpy thing right here. Then it's coming down and then going up. There is a point in there, you can see it at -1, +1/2. If I multiply my output values by 1/2, my output is 1, I get 1/2. So now I'm going to pause and find the domain and range of this. You're going to notice the domain does not change. The range, however, does change. The range changes from -3 to 2, so from bottom -3 to top -2, to bottom -1.5, and the top will actually be up at 1. So -1/2, 1, and I think if you're following me, that what I did, my domain stayed the same because I didn't change my x's. My y's I multiplied by 1/2, which in effect does the same thing to the range. We are going to look at one more transformation. I'm assuming you can kind of see this since this is the number at the end. Remember the number right here in the front, our first transformation was A. This is the very last. This is going to be the D transformation. I'm going to adjust my parent based on what these three do, just like I did in the first one. So just so you know what page I'm on here. This guy, I'm taking my x and I'm subtracting 3. So the beginning point is becoming -3. I'm going to graph these three and then fill in my table. If you look at these graphs, so remember, I'm looking at the blue graph separately than the red and the yellow. So in the blue graph, I just went to the beginning point of -3, and I still have a slope of 1, so I just did my slope up and over, 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 1, 1. Here's my new one. If I fill in the table, at -2, I have -5. -2, -5. At -1, I have -4. So I'm going to -1. Notice I go through -4. At 0, I go through -3. So here's that table. What happened between this and this point each time? Yes, I subtracted 3. The red graph. Notice, if I go to the red graph and find my points now, if I go to -2, I have 0. If I go to 0, I have 2. If I go to 1, I have 3. What happened between these y's and these y's? Well, I added 2. And the yellow, if we do the same, you'll see I added 5 to my y's. Where are those numbers coming from? Well, they're coming from this y-intercept. If you remember from Algebra 1, you talked about what all the y-intercept did was take my line and either shift it up or down. So this shifted up, this shifted up, this shifted down. That's all it does. It does a vertical shift up or a vertical shift down. That's all this number at the end does, is a vertical shift up or a vertical shift down. Therefore, you have 2 new vocabularies. This will ending up being the D transformation. If we look at this, all we had was an X and a number at the end. We had no C, we had no B, we had no A. So this is the D transformation. The D transformation does 2 things. It does a vertical shift up or a vertical shift down. It can't do both. Let's look at some examples. I'm going to pause the video here, and I need you to fill in your table and tell me what the domain and range is of this new parent table that we're going to use. We're going to have 1, 2, 3, 4, 5, 6 points. So in your parent table, you should have 6 points. So your domain and range should be left to right. The left of this graph is at -5, the right of this graph is 5, and I use every x value in between. The domain is bottom, so the bottom of the graph is -3. The top of this graph is +4, and I use every y value in between here, thus giving me the range. So your domain and your range should be this. I'm now going to ask you to put the tables and the graphs on your graphs. Okay, now that we have that, I want to try to explain this in another way. Notice what this new rule is telling me. It is telling me to take my h of x value and add 2 to it. Remember, this is my input, so this is the x. I'm plugging the x into the function, and this value is my h of x. We spoke about this a little bit the other day. Y and h of x can be interchanged. So this value right here is my y value, or it's my function of h evaluated at x value. Okay? All it's telling me to do here is take that value and add 2. So I'm going to add 2 to each of these. And plot my new graph. And what you see is all that happened to this parent function that's in black. Every point was shifted up 2. This point up 2. Even this point right in here, up 2. My line just isn't great. This point, these points in here, everything went up 2. These points in here, up 2. Up 2. Up 2. Up 2. Everything was shifted up 2. Even this point in here goes straight up 2. So where did the shift from there, where did the shift up come from? It came from that 2, which is our D transformation. Let's look at the domain and range. I'm assuming some of you can guess that my domain didn't change. My domain of the red graph stayed the same. It was from -5 to 5. My range now, the bottom of the graph is right here, which is -1. The top of the graph is right here, which is 6. So I went from -1 to +6. This transformation is a vertical shift up 2 units. I can't say by a factor of 2. Make sure you understand that. This is a very common mistake. I cannot say by a factor of 2 because I did not multiply in here. I didn't multiply this by 2. I added 2. I added 2. I added 2 by 2 units. So I shifted everything up 2 units. I'm going to pause. I'm going to let you do this one and figure out this answer. The domain should stay the same. Your range should go from the bottom to the top. From the bottom, which is -7, to the top, which is 0. This is y equals 0 right here at the top. To the bottom, which is y equals -7. Now, find these on your worksheet. We are going to use the same parent as we used for the previous page. So I'm going to put the parent function on number 11 and 13, and I'm going to fill in the table and graph it. Notice I now have 2 transformations. So I have an A transformation and a D transformation. Everything having to do with the X transformation comes right in here with the X. So this is an A, this is a D. So this is telling me to take my output value, multiply my output value by 2, and subtract 1. And I want you to think of PEMDAS. Could I subtract the 1 before I did the multiplier of 2? No. You have to do your transformations in alphabetical order. It will be the same as when we do B and C. You have to do A before D. So the first thing we're going to do here is going to multiply by 2, and then we're going to subtract 1. So we're going to Your new table should look like this. And remember the second column, so this column of y's right here is what I'm going to plot. This is only the first transformation of multiplying by 2. It's telling me the new function is multiplied by 2 and subtracted by 1, so I'm going to plot this x column and this y column. So the first thing I want to point out is that my parents were graphed wrong. I had -5 at -1. Sorry, it should be 5, 1. So here is the result of my new red graph. Okay, so my new red graph has those transformations on it. Now, what transformations are that? Let's first do the domain and range. So please figure out the domain and range. You're right, your domain does not change. Your range goes from -7 to 7. So let's talk about the transformations now on this. The transformations, I can see it was stretched. I can also see it was shifted down from here, down. Okay, now here's the thing that's hard to see from this. This looks like I was shifted up, but remember the first thing I did was stretch this, so it actually stretched up to 8, and then I brought it down 1. Here, I stretched this point up to 2, and then brought it down 1. This one, it looks like I didn't stretch it right here, but I stretched it by multiplying it by 2, bringing it down to -6, and then bringing it down 1 to -7. So your two transformations here would be a vertical stretch by a factor of 2, and a vertical shift down 1. I see those from here. I can get my transformations right from here. That is a vertical stretch by a factor of 2 and a vertical shift down 1. We're going to do one more together on the video. So we're going to do number 13. We've already set up the parent graph and the parent table. This again is the function h of x from the previous ones. This time my a is a -2. This is going to be interesting to see what happens here. And my d is 3. So my a is -2 and my d is 3. This -2 is multiplying by the h, and the 3 is added to the function of h. So I'm going to multiply by 2 first. I have to do a before d. So I'm going to multiply by -2 first, and then I'm going to add 3. So I'm going to multiply by -2, add 3. Multiply by -2, add 3. You can fill in the rest. Be careful down here when I multiply -3 by -2, I get +6. Add 3, that's 9. That should look more like a 9. There you go. And same with the next one. When I multiply -1 by -2, I get +2, and I add 3, I get 5. So I'm now going to, again, plot these x's with these y's. This final y has the transformation of multiplying by the -2 and adding the 3. So your new graph looks like this. Wow. This looks like it was reflected. Up here, these mountains go the same direction. These both point up, these both point down. This mountain's up, this mountain's down. This mountain's down, this mountain's up. What made it reflect over the y-axis? Well, that would be the negative. If you have a negative a, it's going to create a reflection over the y-axis. So let's pause and do domain and range, and then we'll talk about transformations. don't forget, domain and range is bottom to top. Domain is left to right, range is bottom to top. Bottom to top. Bottom of the graph is -5. Top of the graph up here is 9. I didn't have enough grid for the 9. You have 3 transformations, and I'm going to dictate them to you because I don't have anywhere to put them. So the first one is a reflection over the y-axis. This negative does a reflection over the y-axis. I also know that I did this transformation. I stretched it by a factor of 2. Okay, the negative I know is the reflection, so the 2 is the stretch factor. So this is a vertical stretch by a factor of 2. If I were to say by a factor of -2, it would be redundant because this reflection is what happens with the negative. So the negative reflects it, it stretches by a factor of 2. The last one I know from this end is it is a vertical shift up 3. So I lastly have a vertical, it's not going to fit down here. I have a vertical shift up 3. What I would like you to do is complete this worksheet for homework. So I know the video is long. Take a day, take a half a day, and complete this worksheet for homework.